Good morning, students. I am Sonika Lohan, your computer teacher. I hope you all are well and safe at home. So, today we will
start with the new chapter, number systems. So, as long as human beings have been around, we have been counting things and looking for the ways to keep track of the things we counted. So, in the earlier times, when there were no means of counting, people used to count with the help of fingers, stones, pebbles, or sticks. So, in earlier times, when they need to keep track of the things, they used to draw lines or symbols like this. Although they didn't have the names like 1, 2, 3, 4, 5. So, and on some point of time, they also must have felt the need of the names. So, from there, we started calling 1, 2, 3, 4, and in the different languages, there are different names for the numbers. But these methods were not efficient to record the large data. Moreover, recounting and understanding was even more difficult. To overcome these limitations, many number systems were introduced with the passage of time. Basically, we have four number systems: decimal, binary, octal, and hexadecimal. In this video, we are only going to learn about decimal and binary number system. So let's start with decimal number system. Decimal system consists of 10 digits. That's why it has base 10. That is digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The basic number system. So, to understand this, let's take an example. For example, I'm taking digit 123. So, as we know, this is the ones place, this is tens place, and this is the hundreds place. So, when I'm going to represent these numbers, I am going to write them as 3 into 1, 2 into 10, and 1 into 100. So, this means whenever I jump from right to the left, I am multiplying my digits with 10. Again, when I jump from this position to this position, I am again going to multiply my digit with 10. So when I add up my numbers, they become 100 plus 20 plus 3. That is 123. The place value of the digit depends on its position. Now, the rightmost digit is called the least significant digit, and the leftmost digit is called most significant digit. This is your first number system, that is decimal number system. Now let's move to a bit complex number system, that is binary number system. In the previous number system, we had base 10. But in the binary number system, we have base 2. It is the base for all the computer languages, all the computer programming. In the binary, we have two symbols, that is 0 and 1. For example, in the calculator, we are giving input in the decimals, like 0 to 9 form, but it is doing the operations in the binary, that is in the 0 and 1 form. Instead of the powers of 10, it will be the power of 2. Before taking an example, we have to understand the concept of exponent. So, when we are talking about exponent, that means power of something. 2 raised to power 0 means 1. 2 raised to power 1, that is 2 multiply 1 is 2. Similarly, 2 raised to power 2 means 2 multiply 2, that is 4. We will keep on moving like this. 2 raised to power 3 means 2 multiply 2 multiply 2, that is 3 times 2. The answer will be 8. Again, 2 raised to power 4 will be 2 multiply 2 multiply 2 multiply 2, that is 16. So this is the concept of exponent. So every time we go to the left, we multiply it with 2. So if I write it like this, so every time I am moving from left to right, I am multiplying it with 2. Again, multiply it with 2. We keep on moving like this. To understand it more precisely, let's take an example from your book. So, I have a digit 25. So, if I want to convert this decimal digit into the binary digit, I am going to divide it with 2 every time. Because we don't have any other number instead of 0 and 1, so our base becomes 2. So we have only one option. We can only divide our numbers with digit 2. So let's start. When we divide 25 with 2, so our answer becomes 12, having remainder 1. So I write my remainder this side. Again, divide it with 2. The answer will be 6, and there will be no remainder. So I write it here. Again, divide it with 2. So answer will be 3 with no remainder, 0. Divide it with 2. So the answer will be 1 and the remainder will be 1. So now, we finish here. We start writing from this side. So this is our most significant digit. It will be the leftmost digit, and this is the least significant digit. That is the rightmost digit. So we'll be writing downwards. So our number becomes 1, 0, 0, 1, 1. So let's count again. 1, 0, 0, 1, and 1. So this is the example of binary number system. Let's take one more example. The number is 321. Again, as I have told you earlier, we have only digit 2 to divide with. So 2 divided by 321, the answer is 160, and there is remainder 1. Again, 2, the answer is 80, and the remainder is 0. Now divide, the answer is 40, remainder 0. Again, 2, the answer is 20, and the remainder is 0. Again, divide by 2, 10, the remainder is 0. Divide by 2, 5, remainder is 0. Divide by 2. Answer is 2 and there is remainder 1. Again, divide by 2. Answer is 1 and remainder is 0. So, as I have told you earlier, we will be writing from right to left. So, we move downward. This is the most significant digit and this becomes the least significant digit. So, let's count the number. 1, 0, 0, again 0, 0, 0, 1, 0, and 1. So this is how we write. So we can write it like this also, is equal to bracket 1, 0, 1, 0, 0, 0, 0, 0, 1 and 2. This represents that the number has base 2. Similarly, we can represent 321 as this. It means this is the decimal number system and this is binary number system. Hope you understand well. If you have any queries, ask anytime. Thank you.